everybody, we're going to go ahead and jump in with our final topic of truth tables, and that is specifically on these indirect truth tables. But before we jump in and see really what those are all about, let's go ahead and recap just a little bit, right? Way back in the beginning, we set out saying that our goal is to try to find good inferences, right? We want to find out when is it that reasons are good enough for their conclusions, or when is it that reasons can support their conclusions, right? And so that's why we've been setting things up as arguments, so we can make it clear, here are my reasons, here's my conclusion. And then we talked about this idea of validity, right? This idea that, is it possible that my conclusion could still be false even if the premises were true, right? We need to ask, are the premises true also in the first place? But then we can also ask, if my premises were true, am I guaranteed to believe my conclusion? Because if that's the case, then that's a nice strong argument, right? That means that, yes, these premises would support that conclusion. We just need to check, are those premises true? So our idea here is we want to figure out when our argument's valid, right? That's our primary goal, at least in the first 80% of this course, trying to figure out when our argument's valid. In the last 20%, we'll look at another way in which you might think an argument can be a good inference or something like that. But right now, we're looking for this really strong property that my premises guarantee the conclusion. Right, and we looked at an example before. We looked at a number of specific examples of arguments, right? And for more in-depth recap, right, I would suggest to go back and look at those videos. But the idea is we started to notice that, hey, this is about the form, right? This is about the structure of the argument. This form always worked, whereas this form always doesn't. So then, right, that's when we started to say, okay, let's go ahead and build this formal language. That way we can get really careful about what our forms really are, right? When is it that I'm saying that, hey, two things are true versus, I'm not sure which one's true. Maybe it's that one or maybe it's this one, right? That's the or versus the and, right? Or we could say, if this were true, then that would have to be true, right? And so we built up this formal language in order to help us get really precise about what we mean. And now that we have truth tables, right, now that we're able to list out all of the possible truth combinations of these statements, we can revisit, and we did last week, we revisited this question of when are arguments valid? And the idea was, well, shoot, let's go ahead and lay out every possible way that the world could go, right? The world where both A and B are true, the world where A is true but not B, where A is false but B is true, where they're both false. And the idea is, well, if validity is about finding any possible way, right? Is there any possible way for the premises to be true and the conclusion false? Well, now truth tables give us exactly a way of finding that answer, right? I can just go through each row and I can ask, all right, are my premises true? Yes, but my conclusion's also true. So that's not a problem for the argument, right? On the second row, though, we saw, this is a problem for the argument, right? This is a place where the premises are true, but the conclusion isn't. So what we're seeing is it is possible. It's possible to accept those premises, but the conclusion doesn't follow, right? Just because we check off, or just because we verify that the premises are true, doesn't mean the conclusion's true. And that means that this argument is invalid, right? And the idea was if we weren't able to find a row like that, right, that means literally there's no possibility where our premises are true and our conclusion isn't also true, right? Look at all these possibilities here. Here, premises aren't both true, so I don't care if my conclusion is true, right? The point of the argument is to say if they're both true, then we get the conclusion, or if they're all true, we get the conclusion. So second world, again, both of my premises aren't true, so I don't care if I get the conclusion. Both of my premises aren't true, so I don't care if I get the conclusion. In the last world, I have true premises. But look at that. A true conclusion came along for the ride. So there was no place where there were true premises with a false conclusion. So there was literally no possible way that the world could turn out such that the premises turned out true and the conclusion turned out false, right? And so this is a valid argument. And notice this is the same argument we started with way way back here, right? This if A, then B, A, therefore B, right? We now get to see exactly why that works. Or we saw last week, right? Exactly why that works. It's because literally when we look through all the different ways A and B could turn out, there's going to be no possible way where the two premises will turn out true, but the conclusion doesn't turn out true. That's what we mean by validity. If we can find a place where the premises could be true without the conclusion, we call that a counterexample, right? We're saying, no, here's a case where your argument doesn't hold up. Here's a case where I can accept your premises, accept your data, accept your whatever, but I don't have to accept what you're saying follows from that because it's not a guaranteed inference. Okay, so that's an important background for what we're about to do this week, because really what we want to do is we're going to do somewhat of the same process, or at least with the same goal of figuring out really we're going to have the same goal. We're going to be trying to figure out, is the truth table or is the argument valid, but we're going to be trying to speed up the process a little bit, because as we've talked about in the past, when we start adding more and more letters, the truth tables become huge. So if you wanted to do anything like something with 5 letters or something like that, like 5 atomic statements, then you'd have a 32-row truth table, right? And so what is it, like 2 to the 10 is something like 1024, right? So like as we add more and more and more atomic statements, this can get really, really big and bloated and just giant and unwieldy. So what we're going to do is we're going to try to speed this up. So again, main result of last time was we could determine, cool, I can now, if you give me an argument, I can determine, is this a valid argument? And I just need to slowly go through each and every step, each and every row of the truth table, and try to find even a single row where the premises are true and the conclusion isn't true. If I can do that, I've proved it's invalid. And if I've shown through all of the rows that none of them have that issue, right? Anytime the premises are true, the conclusion is also true, then I've proved that it's valid, that there are no counter examples, and I've looked through all possibilities. So again, I just want to emphasize, this is our goal, right? This was our goal, like when we started the whole course, right? Was to try to find, how do I see when my inferences are good, strong, and valid, is our technical term. Now, though, so let's look at a couple of examples of this, just to remind ourselves. Right, so like here, for instance, I can fill in my reference columns. Since the last video, I did fix that bug, and now my truths are on top of my falses, which is much more standard for you to see in other logic textbooks and things like that. And now what I want to do, right, is I want to go through, I want to think about this as premise 1, this as premise 2, and this as my conclusion. And what I want to do is I want to figure out, are there any situations where both premises are both true, but my conclusion isn't? Now, here's the thing. I could go one by one through the truth table, right? And I could say, okay, I've got a true on the left, a true on the right, so this has to be true. True on the left, true on the right, that has to be true. True on the left, false on the right, that has to be false, right? Just remembering how the conditional works. But as we go through this, like I just mentioned, well, I'm going to start getting bogged. It's going to be, this one isn't too bad, honestly. This is only, like 3 times, there's like 24 entries you'd have to do. That's not too bad. But like I said, the more we do this sort of thing, the more painful it's going to be when we have to do like 1,000 entries or something like that. So instead of just brute forcing it, or doing what we might call the direct truth table method, what I wanted to show you is what we call the indirect truth table method. So what we're going to do is here's one way to think about it. We're going to hypothesize that we can have true premises and a false conclusion, right? And we're going to see, does that hypothesis get us into any trouble? Can we falsify this hypothesis, right? So like one way of saying this is like we're challenging the argument, and we're going to see, can it push back our challenge, right? So I'll probably jump back and forth between these two like frames of thinking about it. But the idea is, right, in order for this argument to be invalid, we would have needed to find both premises true with a false conclusion. Right? I would need to find a row that looks like this. True premises, false conclusion. And so what I can do is I could just ask, well, based on this, can this link up? So actually, I'm going to clear my reference columns over there for a moment. Could this link up with potential values over here? Right? Are there values of P, Q, and R that would allow me to put these values here? So let me just say right now, this method is completely extra or right? It's a second way of doing what we already did last week. So as we talk about what we're doing this week, this is maybe one of the first and only times in the course that you'll be able to just revert back to what you were doing last week and still be able to find the same answers. The reason why you might not want to do that is generally, right, when you're given assignments that you're asked to do indirect truth tables, right, your instructor is motivating you to do the indirect truth table by making it super long. So just know that, like, you can do everything we're doing for just determining if this argument is valid. You can do that in the old way where we just fill in the reference columns and we one by one do every cell. Like, that is always a legitimate way to do this sort of propositional logic stuff. But this way of doing it is just a bit faster, and learning how to do it in a different way also just can be kind of helpful in just kind of really internalizing what we're doing here, right? Just making sure that all the considerations that are in the air are really sinking in. So if nothing else, still try to really ingest what's going on here and try to internalize how to do this sort of thing, but just know that if this is feeling a little bit more difficult from last time, this is maybe the one time where you can still revert to the skills we learned last time. Okay, so the idea is, what I want to do is I want to try to find values for P, Q, and R that satisfy my hypothesis. And if I can do that, and I don't have any issue throughout this whole process, well, then I've really found my counterexample, right? I've really shown that, yeah, no, here's a situation where my premises are true and the conclusion is false. So what I want to do is I want to come in and I want to say, all right, based on these values, what can I say about P, Q, and R? So for instance, because I know this conditional is true, like I'm hypothesizing, right? I'm tentatively pretending like this thing is true to see what happens. Well, I can't really say anything about P and Q, right? Because the point is, P and Q, right? In order to know that if P then Q is true, well, P and Q could have 3 different combinations of values, right? P could be false and Q could be false. Or P could be true and Q could be true. Or P could be false and Q could be true. Right? All of those would satisfy my hypothesis. And at this point, I'm not really sure which one to choose. Right? Same thing's going on over here. You're telling me this conditional is true, but okay, so in which way is it true? Compare that to this last line over here, what we're using as our conclusion. If I called this false, well, remember, there's only one possible way that a conditional can be false. Right, let me just bring up the table of our foundational tables, right? So like, as I'm looking at a conditional, right, I look towards the conditional, and the point is, when I was looking at the true ones, well, shoot, there's 3 different ways a conditional can be true. So that doesn't really narrow down what my left and right side have to be. But for this last conditional over here, we're trying to say, what if it was false, right? We're hypothesizing, we're pretending for the time being that it's false. And so if this were to be false, then P and R, we do know what the values would have to be. The only way for if P then R to be false is if P is true and R is false. Okay. So now that I have that, I can say, all right, well, so I can jump back over here and I can say, all right, well, so if P then Q is going to be true, and I already know that P is true, then what would Q have to be? Well, I look over here and I say, okay, I know that my conditional is supposed to be true, but the left side is also supposed to be true. The only row where the conditional is true and the left side is true is this top one. And in that row, it tells me, oh, shoot, well then your right side is also going to be true. Right, so the point here is that based on, right, so first, let's just say this again. We saw, okay, if we're going to try to say that this conclusion is false, the only way for that to happen is if the left side is true and the right side is false. So then, based on that we have P and R filled in, we could go back to this if P then Q, and we can say, all right, so if we wanted this conditional to be true, well, the only way that could work, if now that we know that P is true, is if Q is also true. And so now we can jump over here, our last one, and we can see, did we force ourselves into any issues? And notice we really did, right? We're trying to say that this premise is true, but notice we're saying the left side is true and the right side is false. There's no way that that premise could be true, right? So the point in all of this is that it was impossible for us to actually satisfy that hypothesis, right? We tried to start off with saying that the premises are true and the conclusion is false, and then we tried to work backwards to see, okay, so what would the atomic sentences have to look like in order to make that happen? But the thing is, when we make these two things true and false, this one when we make the first premise true and the conclusion false, the second premise automatically turns out false. Right? So this is another way of determining or finding out that, oh shoot, look, there was literally no possible way for us to make our premises true and our conclusion false. So the point of this is that, right, if we can verify that our challenge fails, then we've shown that, okay, right, like our hypothesis is false. We cannot have true premises and a false conclusion. That's what it means for the argument to be valid, right? So essentially our hypothesis is that this is an invalid argument, right? The hypothesis is that I can find a counterexample, an invalidating row. So we go in and we try to make that invalidating row happen, and based on what we see, if we can make it happen, then we say, oh great, this is an invalid argument. I confirmed my hypothesis. On the other hand, if we try to work backwards and determine what would have to happen to make sure our hypothesis is satisfied and we run into trouble, we say, oh shoot, this is not a valid, or this is a valid argument, right? Our hypothesis that we could challenge it failed. It's valid. It was strong enough to stand up against our test, against our challenge, against our hypothesis that it would fail, right? So let me write this down a little bit more specifically. So process is to do the following. Right? First, we want to hypothesize. Let me make this much more readable. Right? We want to hypothesize that there's an invalidating row. What does that mean? That means putting T under, sorry guys, all of the premises. Back up a little bit. And F under the conclusion. Just like I originally had it here. And then what we're going to do is we're going to work backwards to determine what the sub right? So first, hypothesize, then you work backwards, and then finally, as you're working backwards, if you run into a conflict, then we have a valid argument. If you can create a counterexample row I don't want to repeat myself. Okay. Right? So that's our process. We're going to just start off by saying, well, suppose that the premises were true and the conclusion's false. And based on what, right, then we're just going to work backwards using our foundational truth tables. We're going to say, okay, well, so if you're going to tell me that this is false or that that's true or that this or the other, well, what would these things have to be? And the idea is, as we're going through this, if we run into an issue like we did here, where we saw that, well, there's no way I can make this second premise true based on what I found out these other things would need to be for the other premise and the conclusion, right? That's a problem. That's the conflict we're talking about, right? The point is that as we're looking through this, there's no good answer to what if Q then R needs to be. If you look to the left, it's supposed to be false. If you go to our hypothesis, it's supposed to be true. So there's no good answer for what we can put here. That's right. That's a problem with our hypothesis. And the point is, that's what happens when arguments are valid. There's just no possible way that you could put values down here which would allow for the premises to both be true, but not the conclusion. Okay, I know I'm repeating myself a lot when talking about this, but it's just, this can be so confusing and abstract that it's just good to say this in a lot of ways and just over and over again in different ways and different aspects. So let's go ahead and look at some more examples. So right, we proved that this argument was valid because we were not able to find a counterexample, right? As soon as we tried to find a counterexample, we realized it broke down. So let's look at another example. And I'm going to bring us back to, just so we could have this on our side. So let's look at this argument. So the last argument, let's think about this for a second, actually. It's good to think about these intuitively. It was saying, hey, if P then Q is premise 1, premise 2 is if Q then R, so therefore if P then R, right? And this honestly should be a bit intuitive, right? If our two premises are that P leads to Q and Q leads to R, well then it makes sense, right? We're that just P would lead to R, right? Like, if P being true guarantees that Q is true, and Q being true guarantees that R is true, right? Well, then it makes sense that P being true guarantees that R is true, right? That's just some intuition. We're not relying on that intuition. That's why we did the truth table. But it's good to just, like, as we're doing these, make sure that these things make sense to you too, that we're not just, like, following this. But now let's look at this argument. Let's try to think. It's saying, premise 1, either P or Q is true. Premise 2, either Q or R is true. Does that mean that either P or R is true? Right? It's got like a similar setup to the argument we just did over here, but it's different, right? It's using disjunctions, not conditionals. Right? These are just the little things that you want to be thinking about and aware of as you're doing this sort of thing, right? Like, so when we say we're not relying on intuition, that certainly doesn't mean you shouldn't still be building an intuition, right? Like that's certainly the case, right? Just be building a knack for it. When you read these sorts of things at this point in the semester, this point in the course, right? You should definitely be able to, like, internalize and read these like it's a second language, right? Like, if you're still looking up, hey, is this an and or an or, right? You really should take a step back, go look at the old videos, right, and practice more on the language itself. But at this point, right, we should be able to read these statements pretty pretty easily. And if you're not at that point, right, you should right, be taking a step back to practice a little bit more. But the point is, right, this is going to help us as we go, right? Our intuitions will help us learn the rules and the steps, and as we learn the rules and the steps, we're going to be building more robust, more rigorous intuitions. All right, enough of that aside. Done. Okay, so now let's try to figure out, right, what do we think about this situation? Now, something is... Okay, good. Originally I didn't have the spaces in between my connective and my letters, so it was just reading that wrong. Okay, so now let's go ahead and think. Okay, let's go back to our steps before we look at this. We'll come back to our little toolbox in a moment. Let's look at our steps. Right. First, what we want to do is we want to hypothesize that there is an invalidating row, that there's a problem with the argument. So we want to say, all right, if we're going to hypothesize that there's an invalidating row, I have to put false under my conclusion, and I have to put true under both of my premises. Cool. Next, I need to work backwards. So this is the meat of the process, right? Step one should be pretty straightforward, right? Step one just is a matter of are you able to understand what are your premises and what is your conclusion, right? And hopefully at this point you should be able to do that, but just like with reading the language, if you're not, you should go back to look at your notes in the old videos and reach out if you're still needing any sort of assistance. Working backwards, right, now is when we're going to jump down to our truth tables, right? And so the idea is we want to say, okay, so based on the fact that we're calling this true, and this false, what can we say about P, Q, and R? Right? Well, each of these is a disjunction, right? Each of these is an or statement. So the thing to be thinking about now, right, is of course like our or statement. So let me just bring that into our focus. Before we were talking about those were each conditionals, so we were looking at the conditional truth table. Most arguments, to be clear, are going to use multiple connectives, as we've already seen, but right now we're fortunate enough just to focus on this one. And we can ask, okay, so like, based on the fact that we're hypothesizing that that premise one is true, do we know if P and Q are supposed to be true? Well, no, right? Because just because a disjunction is true, that doesn't tell you if the left side's true, or if it's the right side's true, or if both of them are true. And same thing with premise 2, right? I don't know what Q and R are supposed to be because, well, again, it could be Q is false and R is true, or R is false and Q is true, or they're both true, right? So, like, I only want to put in values when I'm, like, forced to do it. And that's what's happening over here. If I know that P or Q is false, well, then that tells you exactly what P and R needs to be. Or maybe I misspoke there. If I know that P or R here is false, then I know exactly what P needs to be and what R needs to be in order to make that happen. P cannot be true because that would just make the disjunction true. It has to be false. Same with R. If R was true, regardless of P, it would make the disjunction true. So in order to really make it false, we need to make both of those things false. Okay, cool. So we've got a false conclusion, and that's what told us that P and R are both also false. So now I can jump in and I can say, all right, what about over here? Suppose I know that P or Q is true, and I'm saying that P is false. Well, the only way to make this happen is if the left side's false, the only way to make the disjunction true is to make the right side true. So that's what I'm going to do. I'm just going to make that true. So now this is happy, right? Like, yeah, P or Q is true. Just depends on, sure, P can be false, but Q is true, so we're good. Then I can come over here and I can ask, all right, did I run into any problems? Right? Did I force a contradiction or a conflict or a tension in any way? Right? No. Look, we're saying that Q or R is true. That's the hypothesis we wanted to confirm or we wanted to validate. And that does link up with these values. Right? Yeah, sure. If Q is true and R is false, then yes, Q or R is true. Right? So the point is, we went in, we hypothesized that there was a T, T, and F. So let me go back now to our instruction set, right? We went in, we hypothesized true, true, and false. Then we worked backwards to determine, okay, so what would these need to be in order to, right, actually make these true, true, and false? And then we just ask ourselves, okay, so what happened? If, maybe I should put it like this, you run into a conflict, then right? If you run into a conflict, then we have a valid argument. That's what happened over here, right? I made this T and F, and so that made me want to make this false because it was a conditional, and a true left-hand side and a false right-hand side forces me to say that the conditional itself is false, but that conflicts with my hypothesis in the first place, so that's why we said there was a conflict. But over here, right, we don't have that, right? I finished up this. It told me what P, Q, and R need to be, and I went to check, does that right mesh well? Does that fit with what I was saying that Q or R needs to be? And yes, it does, right? So like one way to do a sanity check is just to, now that we know which row is supposed to be our invalidating row, we can essentially let's just go ahead and convince ourselves that we did it right. I'm just going to delete these completely, right? Just to be fully sure that we did this right. And what I'm going to do is I'm just going to pretend I'm doing an old school truth table, but I'm just focusing in on just this one row. Just that one row that would have occurred somewhere around like maybe right here. Maybe this would have been like the 6th row in the truth table, in a normal truth table. So it would have taken us a little bit to get to. But right, I can just go through the process. I can say, okay, P or Q, is this true or false? Well, shoot, it's got a true on the right-hand side. I don't care about the left-hand side then, so I'm going to call it true. Q or R, is this true or false? Well, it's true because it has one side that's being true. P or R, is that true or false? Well, it's false because both sides are false. Remember, a disjunction, right? We're always going to call it true if it's got one of the sides, but we're not going to call it true if it doesn't have either. So, right, we were able to go in and we just checked our work. This right here is a counterexample. If the world turned out such that P and R were both false, but Q was true, then, right, we wouldn't actually get our conclusion. So, like, I mean, and again, we can think about this. So, yeah, I talk about intuition from time to time, and the point is we don't want to rely on our intuition, but we do want to continue to cultivate our intuition to make it better and better. And so, like, let's think about an example for this, right? Suppose one parent tells you, hey, you're either getting a dog or a cat for Christmas. And then another parent tells you, hey, you're either getting a cat or a bird for Christmas. Does it follow that you're either getting a dog or a bird for Christmas? Well, no. Both of those parents might have been thinking, I'm going to give you a cat, right? So both of those parents are telling you true things. But, right, so both of those parents are telling you true things, but it doesn't follow that you're either getting a dog or a bird, right? You're still getting you're getting a cat. So the point is, I can make both of those premises true so long as Q is true. And I can make P and R false, and that still allows the premises to be true. But that situation makes it so the conclusion is false. So all of what I worded out there is precisely what we just found out in this truth table, right? That if P and R are both false and Q is true, the premises would be completely satisfied, but the conclusion would turn out false. Okay, so that's the difference between, right? Those are the two ways, the general ways in which doing these indirect truth tables can go, right? We could either find a problem with our hypothesis, which shows us that, oh, wait a second, this is actually a valid argument. If P leads to Q and Q leads to R, P really does lead to R. Versus, no, there was no problem with our hypothesis, right? We were able to show that there could be true premises and a false conclusion. Okay, let's go ahead and look at another example then. So here we have a 4-line argument, right? 4 premises, and actually let me fix this issue. It's the same as what we had earlier. Only 3 atomic statements, right? But we have 4 lines, 3 premises and a conclusion. So here's what we want to do. The same thing, right? So what we're going to do is we're going to jump in here and we're going to hypothesize that our premises are true and our conclusion is false. Okay. And then we're going to work backwards, and then we're going to see, did we run into a conflict? So reading the argument intuitively, we're saying just either A or B is true, and B leads to C, and A leads to C, so therefore we should be able to get C. So we might intuitively think, okay, there's something going for this one. So let's do our hypothesis, right? Our conclusion has to be false. Our premises have to be true. And we want to see, okay, is there any way in which we can actually validate this hypothesis, that we could corroborate this? Well, one thing is easy. We said that C is false. So we can come over here and we can say, well, okay, C has to be false, right? When one of our premises or conclusion is just an atomic statement, that's really nice, right? It just tells us exactly what that atomic statement needs to be. Okay, good. So now we can jump in at any place, right? If I tried to do this A or B, there's not much I can do. Let me go ahead and bring us back to our rule set. There's not really much I can do because, hey, A or B could be true in, right, 3 different ways, depending on whether A is the true one or B is the true one or both. Right? Same sort of thing. Well, actually, not the same sort of thing going on over here, right? I know my conditional is true, so I'm dealing with a true conditional. But I'm also saying my right side, the C, is false. So how can I have a true conditional but a false right-hand side? And there's only one way to do that, right? This last row down here, where the left side is also false. Right? In order for this to be true, B cannot be true, right? That's the only thing that makes the conditional false. So we need to make B false. And same thing with the if A then C, right? In order to make that conditional true, given that C is false, we need to make A false. Okay, so we have that conditional is happy. It's true based on those things. This one's true based on those things. This is false, right? Just based on B and C. And then we can turn back around to this disjunction that we set aside originally. We can ask, okay, did we run into any conflict? And notice we absolutely did, right? Look, we're trying to say this disjunction is true. This or statement is true, even though neither of the sides are true. That's the only time this thing is supposed to be false. So on the one hand, I want to hypothesize that it's true, but on the other side, the other hand, I just learned that as soon as I make the other premises true and the conclusion false, this one just necessarily becomes false. So that makes this argument a valid argument. Okay, so I'm just going to keep going through these. So now, let's look at yet another example. So this is similar to our first in that we're dealing with a series of conditionals, but it's slightly different. Let's see whether or not we think this conditional works out. So again, we're going to just start with our hypothesis. And then we're going to ask, okay, if I know that this is true, do I know anything over here? No, right? Because there's 3 different ways a conditional can be true, and I'm not being narrowed down to any of them. Same thing right there. Over here, though, I have a false conditional, and I know there's only one way for that to happen. So now I've really narrowed something down, right? I know my left-hand side has to be true, and my right-hand side has to be false. So what's my left-hand side here? Well, it's the red one, right? Red for us is always the left. So in order for that to be false, we need the left-hand side to be true and the right-hand side to be false. Okay? So now we can jump back to our other conditionals. We're trying to say that if A then B is true, but we have A being false. So, right, we look over at our conditional and we see, oh shoot, all right, well, there's 2 different ways for this conditional to be true and the left-hand side to be true. So the point is, right, I don't know if B should be true or if it should be false, right? Both of those are still legitimate possibilities right now. Because if A then B could be true regardless of what B turns out to be, right? As long as A is false, B could be false, it could be true, and we're still good. So we don't actually know what B should be yet. Let's look at our other conditional. We're trying to say this one's true, and again, we're saying that our right side is true, and we're saying that the conditional is true. or right, not again. So this is, yeah, slightly. Before we were saying that our left side is false, and there's two different ways for that to happen. Now we're saying our right side is true. Right? These two right here. There's two different ways for our right side to be true while the conditional is true. So again, we're left with not knowing. Wait, so is B supposed to be false or is it supposed to be true? So the way we can do this, or the way we do this, the way we should do this, is when we go through these things and we find ourselves not forced into any situation, right? Like, I'm not sure if B should be false or if it should be true. What we're going to do is we're going to cover both of our bases, or all of our bases. Sometimes you might not be sure, right, between three different alternatives. But here, right, the idea is I'm just going to copy this whole row down. And the point of that is so that I can look at both cases, right? I wasn't sure, should B be true or should it be false? So now I'm going to look at the row where it's true and the row where it's false. And I'm going to see, will either one of these work for me? And if I can get just one of them to work without an issue, then I know, hey, that's good enough. All I need is one counterexample and the argument is invalid. Because the argument is supposed to tell me, right, for it to be valid means there's literally no counterexample. So we're going to just cover our bases and check both of these possibilities to see would either one of these satisfy and create a counterexample. So we can go through, right? We can see. So, right? So sometimes when we do this sort of thing, we'll still have other gaps to fill in as we go. Right now, we're essentially at our last step already, right? We're just supposed to see, do we have any conflicts? And right here, A and B is considered true, and that works, right? It has a false left and a true right. That fits. A false left and a true right equals a true conditional. Same, right? Another true conditional because the left-hand side is true and the right-hand side is true. We're happy. The last conditional is false, though, right? Because the left-hand side is true and the right-hand side is false. So right there, we're already good, actually. With just this first row, we found an invalidating row, right? If A is false and B and C are both true, well, then the premises will turn out true, but the conclusion won't. So already we can rest assured we have an invalid argument. We have this counterexample row. Now, we don't need to because we've already proven it's invalid, but it can be useful just to go ahead and do the other one as well. Here, again, this conditional is true because it has a false left and a false right. Here, this conditional is true because it has a false left and a true right, right? Both of those are different ways in which a conditional can be true. And finally, we have a true left-hand side and a false right-hand side, and that's what gives us our false conclusion. So this doesn't happen every time that we double down on the rows that both of them turn out to be invalidating. So just be aware of that. Know that like each row is, right, essentially a different challenge, right? But the idea is if we can find just one of them to work, we have shown that, yeah, okay, I can make it so we have T, T, and F. And we might as well just go ahead and we can, for both of these, really do the sanity check. I think the sanity check is just a good practice to have after you've found an invalidating row, just to make sure that you didn't actually run into a conflict you just missed, right? Because part of this is, like, you go through and you need to be able to see, okay, is there a problem or is there not? And sometimes you might just think, I don't know. I don't think so. I don't think I did anything wrong. So, like, to really be sure of that, we could wipe away all of those operation columns and just leave what we think we found as the counterexample, or plural, and we can see were we right. So here, true conditional, because we have the false left, true right. True conditional, false conclusion. I'm going through this fast because this is essentially what we just talked about, but I just want to show you a good way of just doing these sanity checks. Okay, so that's indirect truth tables, right? And the idea is they're really leveraging what we talked about last time, with just making sure we understand what it means to find that an argument is valid using a truth table. And assuming we have that, doing these indirect truth tables is just like really working those muscles out a little bit more. So I went ahead and added another quick step to the rules, and that being the one regarding our multiple lines. Oops, going to the wrong place. right? So sometimes at some point, the rows won't determine what you should do next, right? You'll be told, hey, you have this true conditional, and you don't know either of the value of either side. And so the idea is, in a situation like that, you want to list out that row as many times as needed. So for instance, for a true conditional, you might need to list out that row 3 times, right? And then have the 3 different combinations of your left and right side to make sure you're covering all of your bases. But the point is just in general the same every time. We just hypothesize that we have true premises and a false conclusion. We try to work backwards to see what would our atomic sentences need to be to make that happen. And if we can make that happen, good. We found an invalidating row. We found a counterexample, right? So with our second and fourth examples, that's exactly what happened. We were able to find a world where the premises were true, but the conclusion was false. And again, like the important sanity check there is just delete all of those hypothesized rows and just do it like a usual direct truth table, right? Where you start with just those reference columns, except in this case, you just need to worry about just maybe 1 row, or maybe 2 if you want to show that more than 1 is invalidating. On the other hand, right, in the first and third proofs, right, we ran into problems, right? We were not able to find a truth value to make premise 2 true while making premise 1 true and the conclusion false, right? We ran into issues. And same thing with the third argument, right? There was just no possible way to make it so that the first premise was true, given that the other premises were true, but the conclusion was false. So in both the first and the third, right, trying to build a counterexample was inevitably ending in failure, right? There was just no possible way to create a counterexample. So the point is, like, that's an important feature of some arguments, that some arguments just are uncounterexamplable, right? That some arguments just are valid, that knowing those premises just guarantees that you have a truth in the conclusion. Okay, so that's the idea, right? And again, like I was saying before, right, this is really just working out the same sort of muscles, but just a little bit more intensely or a little bit further that we looked at last time. We're not necessarily doing anything new or like able to answer any new questions than the questions we looked at last time when we were finding invalidating rows in the direct sense of just completing the whole thing and scanning it. But it is a way that is more efficient, right? Will get you the answer quicker. But also, as you internalize this way of doing it, it helps you really just understand what's going on deeper and deeper. Right? When you're able to make these sorts of considerations like, well, shoot, if my conditional's false, then this has to be like this, right? Those are the sorts of things that really, they're really just clear signs that you're actually learning what's happening and that's going on, right? A big part of this is not just to be able to like just respond to things at the time or look up the right thing, but can you actually internalize what's happening here? Okay. So, yep, that's it for truth tables and indirect truth tables. Next time, we're going to be moving on to a really important further topic called proofs before we make our way to probability later. All right, guys, take care out there and stay safe.